See, in books you have all mass-based questions. Anybody can manage. What is there in integration and differentiation? That's why I'm just dragging you people to these ideas. After solving this, if you're interested, you can do this for rough also. Time being, let me take all the surfaces are smooth here. No. Straight away get into the first list out list out all the forces that can do work. Which all forces can do work. So first all the forces that are acting on the system. 3 minutes I'll give time, you analyze it, then I'll come into the picture.
Sir, velocity of A is 2 root 10 and B is 8 root 10 by 5.
Velocity of?
A is 2 root 10, sir, and B is 8 root 10 by 5.
Velocity of the wedge will be root 50 by 3. And the velocity of block will be root 20 by 3. I'll ask you a simple question. Can you apply conservation of mechanical energy? Can you apply conservation of mechanical energy?
Yes, sir. There is no external force.
You cannot apply, no? Everyone is interested getting answer rather than studying. So unless you don't show that only the weight does work, I think you're not supposed to write down the answers, no? To show that, first of all, don't give answer. If you're giving answer, you are cheating yourself. Most of you are giving answers. So without showing that net work done by tension, net work by normal contact, because we are not sure, no? Because you see the system is connected to wall and there'll be tension force acting on the wedge. So there is some sort of external force may act, no? And you can't just go for conservation mechanical blindly. We have to verify. Because only block and wedge is there will become internal. But you see the wedge block system is connected to wall, no? So that horizontal part of string, there a tension will act. So if you're directly jumping and writing conservation of mechanical means it's a very dangerous way of dealing with the physics problem. I'm telling you this is absolutely better called stupidity. So don't give immediate answers, at least for God's sake. Question given immediately answers. Some of you have replied it. Draw free body diagram, show the forces acting. Like previously I did know all, what are all forces acting unless work done by all the forces, that equation you write it, then you have to work out here. Okay, what all you did, come out of that, go for, draw the free body diagram, show all the forces are acting, then how the block and wedge will move, then get into the work energy theorem and see what will happen. You have to get into the question here. You have to really work out. Already we have discussed this problem. You know the forces are acting. Okay, now get into show all the forces, work done by all the possible forces. I'll get into the problem now. Tension T. This is T. So this is about the tension force. The normal contact N1, and here it is N1. The weight MBG will act like this. Then the weight of the block MAG. Then there's a normal contact will be acting. I'm just showing it somewhere because no space, no. Somewhere at N2, I'm showing it here now. About possible direction, the wedge will move.
Left.
To the left, I think naturally everyone knows this. The displacement of wedge is in this direction. XBX, I'll write it. So XW, I'll write it. Okay, this XW will write it. Displacement of block, I think symbols. Okay, displacement of block is what A, that one. XAX, XAY will take it, and the wedge, what happened, will write XW. Now, this will be moving in this direction. XR, no, displacement of block with respect to wedge along the incline. Any from constraint equation, can you write XW equal to XR? From constraint equation. It is purely from constrained equation. Not the displacement. How much distance the wedge will move horizontally, that much what happen, the block will move with respect to wedge along the incline. So this is from constraint equation, I'm writing it. Already we have discussed in laws of motion, I'm carrying on it. Now let's go for the work done. So here, so what we have to do, work done by the tension. So first I'll focus on the tension here. Before that, we should know the displacement of block with respect to ground along X, along Y. So along x-axis, displacement of the block with respect to wedge. XW is what? XB. So I'll write symbols. Displacement of wedge it is. Displacement of block A with respect to wedge B along x-axis should be equal to XAX minus XWX. What is XWX? XWX is nothing but equal to this one, because the wedge is moving along, only along x-axis here. This is what we know, XR. Along x-axis, how much it should be? XR cos theta. I don't know displacement of block with respect to ground along x-axis. And this will be positive, no? Anything directed towards right, only for this relative displacement, this one will be positive, and this will be negative. So XAX is equal to XW XR cos theta minus angle. So what you should write? Displacement of block with respect to ground along x-axis. Similarly, what is the displacement of block with respect to ground along y-axis? So I'll go for it. Y displacement of block with respect to ground along y-axis. This should be equal to YA so this should be equal to XR sine theta. And the block what happen will have, and the wedge will not move along y-axis, no? So take this equation. So now we got this much of information. What is y? Y means vertically down. X means horizontal direction. Let's come for the work done by the tension. Look at the tension acting on the this one. T minus T cos theta. So work done by the tension on the wedge. The work done by the tension on the wedge. So first I'll calculate work done by tension on the wedge. Separately we'll calculate here. So T minus T cos theta into displacement of wedge. Keep it here. This is the thing. So work done by tension on the block. Component of tension will act along X and also along Y. No? So if you resolve this tension, so here I'll draw one diagram. There's a block A. The tension is acting here. No? So resolve this tension into two parts. This will be T cos theta. This will be T sin theta. So T cos theta into XAX. And how T sin theta? T sin theta will act perpendicular to that one, opposite to YAY, vertical displacement. So this will be T, symbols, little bit confusion. Okay, let me substitute all this one. T cos theta. What is the XAX? We have XR cos theta minus T sin theta. YAY will be XR sin theta. What is T cos theta? XR. Look at these values. T cos theta, XR cos theta. Here T sin theta, XR sin theta. So if I add up these two, no, is that condition okay? Displacement, what we have taken here towards right, no? Let me do one thing here. The tension, the block, we are moving, no? So that this should be negative. Huh? XR cos theta will come like this. Here you see this one. XR, I took it. XW, I'll take it positive. Because again it is. So this will be XAX should be equal to XW minus XR cos theta. Because I defined XW positive. Some small, this one. If I, towards left, if I take positive, no, towards right should be negative here. So look at the, all of you look at, I made some changes here. Y plus minus sign. The wedge will move towards left here. XR cos theta will be towards right. So therefore, these two should have opposite signs. And towards left, I'm taking positive. So I'm getting this value at this much. So here it should be XW XR cos theta XW minus, come for this one. Now, what is the next part of the problem? So further we'll simplify it. T cos theta XW, T cos square theta, TXR I'll take outside. I'll take common. So this will be cos square theta I'll scroll up a little bit. Yeah. So this should become t cos theta xw minus txr. The bracket term will be 1. Now, what is xw? Xw should be equal to what? Should be xr, no? Anything simple or xr you replace with xw. Bracket.
Why, sir?
Constant equation ma here. Xr equal to xw, no? Already we have assumed it. Constraint equation. So now t cos theta xw you take outside. So this should be the work done by tension on the block. This should be equal to xw you take outside, t also, t cos theta minus t into xw. Look at the work done by the tension on the wedge and work done by the tension on the block, how they are. If you take minus common, equal and opposite, no? So therefore, net work done by the tension on the wedge plus block. What you can write it now? T minus t cos theta xw so this should be equal to how much? 0, no? This is very important. A student has to really fight with such ideas. Huh? This is very important.
Sir,
Yeah.
sir, what is the direction of x-axis, sir?
Direction of
X-axis.
is a positive, no? X value I should substitute here. That will be towards left, positive only. Anything directed. See, it all depends upon here directly what displacement of block with respect to ground along x-axis. That I brought it here. I substituted value of x.
Okay, sir.
Okay, this is about the work done by the tension. So it's not that easy. Something we have to really go to the deep into the free body diagram, workout, displacement, everything. Then we can conclude here. Okay, this is about. Let's get into now normal content. The problem is not at over. Again, we have to fight for the normal contact. Work done by the normal contact. The complete description of the problem, what all we did, it's here. The conventions you have to be a little bit careful. Positive, negative. If you want, I'll write it because some students will take towards right as positive. So here I took it this as positive. Fine. And downward as positive. So here rather than for displacements only. So for the work done, what happens if the force acts in the direction of displacement, work done positive. So therefore, this is you should not apply this convention for the work done. So therefore, in the diagram showing will be very dangerous. Getting this one, that's why I try to avoid. So if you want, here only it's there, no? Towards left positive, towards right negative. Only for displacement, not for work done. Work done, you should not give any sign. If force acts in the direction of displacement, positive. Opposite to displacement, negative. Finish over. Getting the idea? Now, next part, work done by normal contact. We have to show where all normal contact forces acting on the block and on the wedge, no? So work done by normal contact. How much it is? N1 sine theta into xw. Is it clear from the diagram? I'll paste this. Let's proceed here. I'll come for. So let's get into the work done by normal contact. Work done by the normal contact on the wedge. First we'll take it. On the wedge, only n1 sin theta is acting, no? N1 sin theta and into xw. So n1 sin theta into xw. Keep it this much. It's quite very easy. What about the on the block? The block will have displacement along x, along y, no? So on the block, n1 will resolve this n1. n1 cos theta, n1 sin theta. No, n1 sin theta. How it will act? Opposite to displacement of the block A, no? We took xax towards left, xw towards left, xax towards left, and xay downward. How the displacement of the block with respect to ground. So here I think I'll give one small diagram because you can't imagine everything. The block, you know, xax is like this and xay is like this, n1 sin theta is like this, n1 cos theta is like this. Now easily you can write the equation. So work done by the normal contact on the block. So minus of n1 sin theta xax. Work done n1 cos theta. Why negative signs? Why negative signs? The force n1 sin theta is acting opposite to displacement of block A with respect to ground along x-axis. Keep it here. What is xax? Xax we have brought it, no? xw minus xr cos theta. So finally I'll end up with only n1 sin theta, remaining all cancel out. So net work done by normal contact on the block, on the wedge plus block. How much it should be? n1 sin theta xw so it has become 0, you see, finally. So it's we have to be very careful, no? So we can't take it things for granted. So definitely in advance, so they will ask you problems where you'll go wrong. So what is the net work done by the tension in normal contact acting between the block and wedge? Will be 0. Then what is the only force doing work? The gravity. So therefore decrease in potential energy, MAGH should be equal to MAVA square plus MB PB square. But what is VA? VA is the speed of the block with respect to wedge. So speed of the block with respect to ground. But we don't know speed of the block with respect to ground. How to bring that? Again, one more big trouble. So what is the thing that happening here? I just this problem I took because so almost maximum concepts are covered here. Now you see this. The wedge will have speed and we don't know. We have only speed VR. Will I agree? Now you should not write MAVR square, speed of the block A with respect to ground. But we don't know VA, what we have. And from constraint equation, VB equal to VR. Will I agree? Constrained equation it is. So can we calculate speed of A? I think we have to go for vector diagram. So what is the vector diagram shows? VB like this. This is the direction of VB bar and this is VR bar. This is the angle theta. Now I should conserve mechanical energy, no? Because only the weight is doing work. Based on what? Conservation of mechanical energy. Decrease in potential of block equal to increase in kinetic energy of block and wedge. But we don't know VA. So again, I'll go for this VR, that one. What is VR? VR means speed of the block A with respect to B it is. So this vector diagram will come like this, VR, and this will be the VA. VB plus what is VR? VA minus VB. So we'll get VA, no? So what is the angle between VB and VR? Angle between VB and VA, like a VB and VR, that one, 180 minus theta. So how to calculate the speed VA? VB square plus VR square plus 2VB VR cos of 180 minus theta. And VR is equal to VB, and from the constant equation, what is VB equal to VR? So this everything will come outside. VB equal to 2 into 1 minus cos theta. Since VB equal to VR. Okay, that value of VA, now you substitute, you'll get the speed of the wedge, then speed of the block. Answers, I'll write it. Do calculation later on. Almost all concepts are included here, almost all ideas. Velocity of the block will be the velocity of the wedge. The velocity of block will be, this is the velocity of block. Velocity of the wedge will be phi 2 root 3. Okay, these are the speed of the blocks.
Sir, sir, once can you show our displacement convention, sir?
Displacement here, see, like, don't write positive, negative towards this one. So for displacements, what happen? You can write it here, x, anything. Only for displacement this is. Because when you are writing work done, no, the work done positive, negative depends on what? The angle between the force and the displacement. So therefore, don't show that positive, negative sign near the diagram. It's a wrong information it will be giving. So this should be the convention for displacements.
Okay, sir.
Do check later, calculations you can verify later on. I'm just giving all the maximum information. So just be careful. So you should not jump directly to conservation of mechanical. All of you got this. This will be very dangerous approach for you in the advanced exam. Definitely they may ask you a problem where you need not to conservation of energy will not be conserved, mechanical will not be conserved, then that course totally will become wrong, no? I'll leave it to you. You try this one, the same concept. Can you try these things also? The same similar. I'll supply the answers later on. I'll just leave it to you. Come for this one. Here no much mathematics there. Read the question. A block of mass m is slowly hauled up hill by an external agent